All right, Algebra 2, we're moving on to Chapter 6. We are in Lesson Chapter 6, Section 1, and we are talking about roots of real numbers. Our essential question today is, can you find roots of real numbers? Remember, I've had you memorize your squares from 1 to 15, everything squared. You should still know those. You also memorized all of your cubes from 1 to 8, and you should still know those. These are ongoing things that we need to know. Now, I'd like you to be familiar with the following. 2 to the 4th power is 16. 2 to the 5th power is 32. 2 to the 10th power, you don't really have to know it, but I do see it every once in a while, so I ask you to be familiar. It is 1024. All right, 3 to the 4th power is 81. Just think of 9 times 9. And 3 to the 5th power is 243. So today, a lot of these that we're able to do, we can do in our calculator, but I do want you to think about it because you do have most of these known. The cube root of 125. You should know this one by heart because I did have you memorize it. What is the cube root of 125? Good, it is 5. Now, what happens if we have the cube root of negative 125? Does this work out? Is negative times negative times negative a negative? Yes, it is. So in this case, it's going to be negative 5. So stick with me here because some of these will not work out. What is the 5th root of negative 243? This is one I just told you to be familiar with. We know that the 5th root of 243 is 3, and because it is an odd number, it can be negative. All right, let's look at this one. The 4th root of 0.0081. We should look at what we know. We know the 4th root of 81 is 3. But we have to understand how to do this with the decimals. How many decimals are we going? Let's see, 1, 2, 3, 4. So if we have 4 decimals and we have a 4th root, we know this is just going to be a 1 decimal answer. So the answer is 0.3. So please be aware, you're going to see a lot of these. You don't need a calculator. You should be able to do these without a calculator. A lot of our quizzes are without a calculator. A lot of our tests are half and half. So half with a calculator, half without. All right, I do have a star circle highlight here for you. So notice my star circle highlight gives us a little suggestion. When solving for x squared, you need 2 solutions. You always need a positive and a negative solution. So if I was to solve this x squared, I would take the square root of each side. When I do that, I guess I'll just drop it down here. I'm going to have x is equal to, well, I know the square root of 49 is 7. And again, this is a square root, which has an invisible 2, and I have 2 decimal places. So this is going to be a 0.7. Now, what a lot of us forget is this plus or minus, because remember that a positive 0.7 times a positive 0.7 is 0.49, and a negative 0.7 times a negative 0.7 is 0.49. So if it is easier for you to see it, maybe the best bet is to stick with that rule, make all quadratics equal to 0. When I make all quadratics equal to 0, I forgot my decimal, then I could factor this to be x plus 0.7 times x minus 0.7 is equal to 0. So x will equal negative 0.7 and x will equal positive 0.7. So if it helps you to remember to factor, that may be a good option for you. All right, moving on to more solving. All right, here we go. We have 3x squared is equal to 432. The first thing I have to do is just simple algebra 1. We have to just divide by 3. What I do to one side, I do to the other. And I have x squared is equal to 144. I'm going to take the square root of each side x is equal to not just 12, but positive and negative 12. So don't forget, when you're solving for that x squared, you need that plus and minus. Moving on, 5y squared plus 45 is equal to 0. First step, good old algebra 1. We're going to subtract 45 to each side. 5y squared equals negative 45. Divide each side through by 5. Y squared is equal to negative 9. What happens when I take the square root of each side? Notice the square and the square root cancel out. So we get y is equal to the square root of negative 9. Can I have the square root of a negative number? No. So right now we're going to have no real roots be our answer. Eventually we're going to learn about imaginary roots, but we're not going to do it today. So at this point right now, we're going to write no real roots. All right, moving on. We have 4z squared minus 24 equals 0. We're going to add 24 to each side. 4z squared equals 24. Divide each side by 4. Z squared is equal to 6. When I take the square root of each side, z is equal to plus or minus the square root of 6. Now, you can leave your answer just like this. I repeat, I do not want it in decimal form. You want to leave it in radical form. So we always want to leave it in radical form, because this whole section is talking about these roots. So we're going to get into a lot of good stuff where you want to leave it in radical form. All right, do y'all know this one? The square root of 0.0004. Remember that square root is 2, and I have 1, 2, 3, 4. I know the square root of 4 is 2. And when I have 0.0004, I'm going to take this 2 and divide it into this 4, so I should have 2 decimal spaces. So my answer should be 0.02. What about this one? Negative square root of 49. Order of operations tells us to do parentheses, exponents. Okay, in this case we don't really have a parenthesis, but we have a radical. So we're going to drop the negative down, and then we're just going to take the radical of 49, which is negative 7. The answer here is a negative 7. You can have a negative when it's on the outside. But what happens when I have a negative on the inside of the radical? Square root of negative 49, there are no real roots. All right, at this time, there is a blue box on page 261, and I would like for you to push pause and open your book to page 261 and read that blue box. It says the nth root of b, all of it to the nth root, is equal to b. It says the nth root of b to the n is also b, if it is odd. And then it gives us this funky little thing that I'm going to talk about. Okay, it's telling us that if I have the square root of an unknown squared, it is equal to the absolute value of a. Now, remember, I can't have an even radical with a negative. So this is why we have to put it into that absolute value. So I make up a little rule. When we have an even radical and an even exponent, and out comes an odd, we want to put it in absolute value. Now, these get a little trickier because we need to know how to factor. So once again, we're going to say those rules. Factor first, factor first, factor first. If I am to factor y squared plus 6y plus 9, that is y plus 3 quantity squared. Notice I have an invisible 2. I have a real 2. 2 goes into 2 one time. So I know that I'm going to have y plus 3, all of that to the first power. But because of this rule that we have right here that you can't see anymore, we have to put it in absolute value. So please be aware of that absolute value, and we'll try a few more. What about the fourth root of a to the fourth power? 4 goes into 4 one time, a to the first, even, out comes an odd. We're going to put it in absolute value. Couple more. I know, the longest lesson ever, right? X squared plus 4x plus 4. We do have to factor first. The perfect square of this, the factors of 4 that add up to be 4 are 2 and 2. So we have x plus 2 quantity squared. Invisible 2 goes into 2 how many times? Good, one time. And because we have even, out pops an odd, we need to put those into absolute value. All right, last one. If I have 6 dividing into 6, I have a to the third power. We have an even, out pops an odd. Do we need absolute value? Yes, we do.